Hello, this is Sergey, and this is Debugging Galaxy tutorial, last section, runtime error. So now we're going to be learning how to fix a runtime error in Galaxy. So sharing my screen and heading over to the tutorial. So the last error happens at runtime, and that means that we don't have a failing test. Instead, we have a bug report describing the error. Our goal is obviously to fix the error, and our steps are going to be as follows. Step 1, reproduce the error. Step 2, locate the error in the code base. Step 3, identify the problem, as in what exactly is causing the error. Step 4, write a test exposing the bug. The test obviously must fail. Step 5, fix the error. Step 6, ensure the error no longer occurs. Let's head on to the hands-on section. And part 1 is reproduce the error. So here is your bug report. In the user menu, clicking the datasets option causes an error message to be displayed on the page. Uncaught exception in exposed API method. What do? We reproduce the error. So make sure you are in Galaxy root, then start your Galaxy. So obviously you head into your terminal. I head into my terminal, present working directory. I am in the Galaxy root, or rather in the Galaxy root of the repo that I need to be running at this moment. And according to the tutorial, I need to start it with run.sh. So run.sh. Oops. If you are starting Galaxy for the first time, it might take quite a few minutes. If not, then you should be able to see a running Galaxy in just a few seconds. Waiting. And here we are, starting server, serving on HTTP 127.0.0.1, port 8080. Heading back to the tutorial. So of course the process ID number will be different in your case. But now we can access Galaxy. We can access it from the browser at this address. So I will just go ahead and open it in a new tab. And we have a running Galaxy. Back to the tutorial to make sure we are following the steps. So to reproduce the error, we need to access the user menu. Now, to access the user menu, we need to be logged into Galaxy. So I'm going to, again, back to Galaxy. I'm going to click the user menu. Aha, and I'm logged in. So I will log out. I will pretend this never happened. Back to Galaxy. Back to the user menu. The user menu does not exist, so we need to log in. If you don't have an account, and most likely you do not on this version, you need to register. So I click login or register, and at the bottom of the form I see don't have an account, register here. So I click register here and create a Galaxy account. Email address. It really doesn't matter what email address you use for this exercise as long as it is a valid email address. So we will use, let's see, I think my email address exists in the database, so it won't let me use it. So I'll use something else. For lack of a better example, password. I believe the minimum number of characters is 6, but they can be any characters. So I'll just do 111 111 111 111 and create. We're in. Now, so we need to access the user menu and do something. Let's double check. Now the user menu is available to us. Click user, then select datasets from the drop-down menu. You should be able to see the error message displayed on the page. Okay, user, datasets, Wonderful. We have an error message, unquote, exception in exposed API method. So this is actually very good. We were able to reproduce a bug. This means we're on the way to fix it. This means we know exactly where to start looking for it. In the wild, in the real world, it is not uncommon that a bug is not easily reproducible. So fixing it is not a trivial task. Heading over to part two, locate the problem. So to figure out what's happening, our best bet is to look at the Galaxy log. So let's take a look at the terminal window from which we launched Galaxy. The question is, can we see the error message? Terminal, let's take a look. So this is the Galaxy output log, and if you look towards the bottom of the screen, you'll see these very suspicious lines which say file lib/galaxy/webapps/ and so on and so forth, line 129 in index, raise exception. This should not happen. Exception, this should not happen. This most likely is exactly what we're looking for. Let's double check the solution in the tutorial. And indeed, you should see something like this, and it gives us the summary, well, a screenshot of the lines we just looked at. So what's important is that from this error log, we can easily tell that the error happens in the datasets.py file on line 129. And the specific error message, well, it doesn't tell us much, which is often the case, but not to worry, this is a start. So let's head over to datasets.py. So back to the terminal. I believe I can get out of Galaxy, so I just clicked Control-C. And I need the file, where is it? Here it is, file, lib galaxy web apps galaxy API datasets by. So lib galaxy web apps galaxy API datasets, and that will be line 129. And here it is. Great. Raise exception. This should not happen. Back to the tutorial. So the good news is that the error happens inside an if-else block, which narrows down our search to line 126. That line evaluates to false, causing the else clause to execute. And of course, the bad news is that we have no idea what exactly causes it. So once again, if we take a look at the terminal, here it is, line 126, which is if stir as bool or string as bool, it takes the argument is trans.app.config.get, and in parentheses it's show datasets, comma, true as a string true. If this evaluates to true, then the return value will be something else, which obviously is not happening. Else, so if this value is not true, as in if this value is false, then the exception, this should not happen, will be erased. So this is a good start. Time to head to part three, identify the problem. So we will investigate using PDB, which is our trusted Python debugger. PDB is great. It offers a wide range of functionality. It's exceptionally useful for debugging at runtime. I encourage you to read its documentation, and let me click the link and show you what it looks like. It's not scary, and again, it's exceptionally useful. Here it is. It's on python.org. You simply head into documentation, then the standard library. You simply search for PDB or debugging, and you'll see the link immediately. And this will take you to the documentation for the PDB module. So the documentation is not long, and in fact, you will need to read it once. It'll take you 20 minutes, and then the debugger commands right here is all you need to navigate code bases of arbitrary complexity. So that's PDB. But let's head back to the tutorial. So the functionality offered by PDB is broad, is impressive, but we are going to use the simplest functionality it offers, which is the built-in breakpoint function, which simply drops you into PDB and lets you use it as an interactive Python shell. So first of all, let's add a breakpoint statement to our code right above the if-else block. Back to the terminal. So here is our if-else block, and again, we are in the datasets.py file, and we're going to add a breakpoint right here. And again, breakpoint is a Python built-in function which will drop you into PDB as soon as the interpreter, as soon as the execution reaches this line. So we've added breakpoint. Let's double check the solution in the tutorial to make sure that we're doing the right thing. Solution, yes, we did the right thing. Now we need to restart Galaxy. However, here's one thing. To use PDB, we need to enable Galaxy's debug configuration option. In general, it may be a good idea to enable this in your galaxy.yaml configuration file. So what you can do is you can head over to config, and there will be a galaxy.yaml.sample file. You can copy that file into galaxy.yaml and simply uncomment the option you want to set and set it accordingly. Of course, for the purposes of this exercise, it's enough to set the Galaxy config debug environment variable when running Galaxy. So what we can do is galaxy_config_debug equals 1 and then run it. So Galaxy config debug equals 1 and run.sh. Waiting for Galaxy to be served. And we're good, it's serving. So back to Galaxy. Here's our Galaxy, just to make sure that it's running correctly. Yes, and we retrace our steps. So we go to user, datasets. Something different is happening. We don't see the error message, but definitely something wrong is happening. Loading datasets, the datasets have not loaded. So what we do is we head over to the terminal from which we launched Galaxy, and we take a look at the log, or on the terminal, and we see exactly what we were hoping to see, the PDB, the Python debugger prompt. There it is, PDB in parentheses at the bottom of the terminal. In case the captions in the video might block this, let me just do this so you see this PDB prompt. Heading over to the tutorial to make sure we are doing exactly what the tutorial expects us to do. So at the bottom of the log, you'll see something like this, and yes, that's exactly what we're seeing. We are at the PDB prompt. From here, you can execute Python code interactively. So let's explore what's happening in the next line. Well, let's head out to the terminal. So if you look at the top, well, at the bottom line of the terminal, the line right above the PDB prompt, it is the line which would have been executed if we had not added the breakpoint. So string as bool in parentheses trans.app.config.get and arguments. So let's explore. Let's see what's trans. Trans is an instance of Galaxy Web Transaction. What is transapp? Trans.app is an instance of the universe application class. What is transapp config? Transapp config is an instance of Galaxy app configuration. Finally, what is get? Well, it's a bound method, so it's a method of the Galaxy app configuration class defined in common configuration mixin. All right, back to the tutorial. So we've done some exploration, we got some context. Again, yes, we could have typed trans.app.config.get, we would have gotten the same result. But what we did, we explored a little bit. Now we know what object is calling what object, or we have a much better idea of the code we are going to debug. So that was useful. So let's take a look at the definition of this get method. And again, the method is defined in the common configuration mixin, which is used by galaxy.config.galaxy app configuration. How do we know it? Well, we got it from the definition of the, well, not the definition, but from the string representation of the get method right here. So let's head on to libgalaxy config init. And I don't want to exit the Python debugger, so I'm going to create a new terminal window. I'll keep it here. I'll go into the same directory right here, and I will take a look at that config class definition. So libgalaxy config init. And in the config, I'm looking for, let's see. Once you find it, look for the definition of its get method. So I'm looking for the common configuration mixin. Let's find common configuration. Here is the common configuration mixin. And I need the definition of the get method, and not this. Here it is on line 480. Luckily, it's a very simple method. So it takes key and default. It has two parameters, key and default. And the only thing it does, it redirects this to self.config.dict.get, a similar method. So let's see what the tutorial says about it. Once you find it, look at the definition of its get method. When you find it, look at the method signature. What is the meaning of the argument true that is passed to the method in datasets.py on line 127? So datasets.py, it's the file we were discussing when we were looking at the Python debugger. So why don't I open that datasets.py side by side with the config? Where does it live? Well, if you look at the PDB output, it lives in, here's the line, lib/galaxy/web apps/galaxy/api/datasets.py line 127. That's the line we've already looked at. So, oops. So let's open it side by side. Lib Galaxy Web Apps. Again, Galaxy, API, and datasets.py, line 127. Here it is, string is bool. So the question in the tutorial, once again, what is the meaning of the argument true that is passed to the method in datasets.py on line 127? So trans.app.config.get, we pass show datasets as the first argument and true as the second argument. That's on the right screen of line 127. The method, this method get, is defined on line 480 on the left screen. So you see that true is in fact the parameter which is called default. And this default is passed on line 482 to self.config.dict.get as this second argument. So heading back to the tutorial, let's open the solution. And this is exactly the code we were looking at in the terminal. So the argument true corresponds to the parameter default. In the method's body, we see that the value will be passed to self.config.dict.get. Now, self.config.dict is a Python dictionary. And we can discover that by looking at the code for an extra 5 minutes. You will find it very easily. So it's a Python dictionary. And you call its get method. And we know that the get method called on a Python dictionary, the second parameter will be a default value that will be returned if the key is not in the dictionary. So back to datasets.py line 127. So now we know that true is the default value that will be returned if the key show datasets does not exist in the config dictionary. Take a look at this code in the terminal. So here it is, right side of the screen, line 127. If this key, show datasets, does not exist in the config dictionary, then this code will return this string, true, as the default value. So this is something we have already established. Back to the tutorial. So moving on, back to PDB. Let's make sure we are in the right terminal. Here is our terminal. We are in PDB. And according to the tutorial, what we'll do is we will try to experiment a bit. Let's call transapp get config without the default argument. So show, what was it? Show datasets, I believe. Double check that it's indeed, yes, show datasets. So when we try to get the value of the key show datasets and don't submit a default, we get none. And none will be evaluated as false. Well, it means that that key does not exist. Now, what if we execute it, we pass true, is it a string? Yes, it is a string, true, as the default. And we get true, as expected. All right, progress. So now we see that show datasets does not exist, and we get the default value, which is the string true. Next step, string to bool or stir to bool. Again, back to the tutorial. And why do we care about string to bool? Because if you look at the very first line above the PDB prompt, you will see that this is the line at fault. So we were looking at the argument passed to string as bool, which is trans.app.config and so on and so forth. Now let's take a look at how string as bool behaves as a function. So string as, first of all, is it a function? Yes, it is a function. Now, what if we pass it? Let's see what the tutorial wants us to do. The tutorial wants us to pass it the value true. Why are we passing it the value true? Because that is, we have established that the argument we are giving string as bool, this trans.app.config.get, show datasets true, all this evaluates to the string true. So we're just simplifying this. So that's what happens. And we pass it and we get false. And this doesn't look right at all. So I think we found it. So exit the debugger. To exit the debugger, we type Q, enter. We're back in Galaxy. Control C to exit Galaxy. Back to the tutorial. Head over to the function definition. You can tell from the import statement at the top of the file that it's in libgalaxy util init. Let's take a look at the import statement first. So heading to our terminal, we don't need the config anymore. So I'm closing it. So now we are in datasets.py. We are interested in finding where string_as_bool came from. So I'll go to the top of the file, and there it is, line 21. From galaxy.util import string_as_bool. So I'm heading into galaxy.util. I'll just open it as side by side again. Galaxy util string_as_bool. I don't see a module, so it has to be in the init module. In fact, I don't need the left side anymore. So I am in Galaxy util, the init module, and I'm looking for the string as bool function definition. And here it is on line 103. Back to the terminal, back to the tutorial. And try to figure out, so head over to the function's definition. We have found it, and try to figure out what if there is an error. Well, let's take a look. So what are we looking for? We just called this function, and we passed a string value true, and we got false as the return value, which made absolutely no sense. So can we figure out what's going on here? Well, if the argument we passed is in this tuple, and the tuple contains true, yes on one, then return true, but we got false. Why false? Can you guess what was the value we passed? Let's take a look at the tutorial. At first glance, everything seems right. It always does. And if you think of the value we're passing, true, it is not in the true, yes on one tuple, because true starts with an uppercase T. So apparently the developer did not account for upper versus lower case. So most importantly, do not fix this error. First, we're heading into part 4, and in part 4, we will write a test exposing the bug. So this code is not covered by a test. Therefore, it is imperative that you write a test to expose this bug so that it doesn't happen again. In this case, we have a simple, completely isolated function. Again, here it is, string_as_bool, a very simple function. It has 0 dependencies, so it's very easy to test. A simple unit test will do. So start with a blank, let's see. Our unit test should go into test/unit/util/testutils.py. And we need to start with a simple blank test function. Then in that test function, we will call the function under test, string_as_bool, and assert that when you pass in the value true with an uppercase T, it returns true. Let's not think about what other cases we need to test. Let's just do this. So we are going to we're going to open the test util module, which it's located in test/unit/util/test_utils. And you might recall that the first function, test strip control characters, is from the first part of this tutorial, the test unit, fix the unit test failure. So now we're going to add a new unit test. We'll call it, we're testing the string_as_bool function, so we might as well call it test string as bool. And we need to assert that when we call it with the argument true with an uppercase T, it returns true. So this should do it. Back to the tutorial. Run the test. Well, let's run this test. To run this test, as you remember, you need to be in Galaxy root. We are in Galaxy root. You need to have your virtual environment activated. So we will activate it now. Dot space dot venv bin activate, and we have the venv prefix. And now we use pytest to, I suppose, run the test of the entire module. So pytest test slash unit slash utils test utils. And it failed. Did it fail? Yes, it did. Good. Now it's time to fix the error. Why is it good? Because this is exactly what we expected from it. So, part 5, fix the error. Can you think of a simple way to fix the function so that the test passes? Well, let's take a look at the function once again. Lib galaxy util init module string as bool. Here it is. Can you think of a way to test it? Oh, to fix it. Getting back to the tutorial. One way to do it is to simply convert the input value to lowercase, and that indeed will do it. So if string dot lower, so what is it going to do? It will take our string argument and it will convert it to lowercase and then test against this tuple of lowercase values. So casing of the argument is no longer relevant. This should pass. Let's double check. I mean, let's run it now. Let's run the test. And it did not pass. I know exactly why it didn't pass, because it says that string as bool is not defined. And what we did is we assumed, oops, we should open the test. There it is. So we called it a string as bool. We assumed that it's imported. It's not imported, but the util module on line 6 is imported. So this should fix it. And now it should pass. Now it passes. And now, since we got the wrong error, let us, for just a moment, unfix the error, this one. So this is what our file looked like before we so cleverly fixed it. Now let's rerun the test. The test fails, but now it fails for the correct reason. Assertion error, assert false. This is what we expected. So now we can go back into the function definition module and fix it once again. So again, we add the dot lower method, save and quit, and rerun the test. Now everything passes, and everything passes for the correct reason, for the reason that we fixed it. Back to the tutorial. So one way to do is to simply convert the input value to lowercase. That's exactly what we did. In fact, that is exactly what the real function does. Check line 966. You'll see almost the exact function named string as bool. So line number 966. Let's take a quick look. So our function is here on line 103, and line, let's do it this way, 966. And here is stringers bool on the right, line 966 in the same file. So the solution is exactly the same. Dot lower. This is the real function. Why we didn't alter the real function? Well, because the real function is a utility function that's used all over the Galaxy code base. So essentially, Galaxy would have exploded in our face. It wouldn't just create this little bug. It would not run at all. So run the test. Now it should pass. We did it. Heading into part 6. Ensure the error no longer occurs. Now that we have the stringers bool function covered by test, as a bonus, we can safely do some minor refactoring. The test will prevent us from breaking things. Can you simplify the code, the function's code? Let's take a look at the function. It's line 103, I believe. Yes. So let's take a look. Again, the function is covered by a test. So now we can play with it. Now we can make it better and not fear that by making it better, we are going to introduce some other bug. Well, let's see. If something, return true, else return false. So how can we make it better? Well, there are several ways, but the most obvious way, if you think back to your computer science 101 days or to the first book on programming you ever read, you can just do return this. You don't need, if something is true, then return true, and if not, then return false. Just return this. There. Much better. Elegant, beautiful, simple, a pleasure to read. Back to the tutorial. Is that the solution? Indeed, that is the solution. But one more thing we need to do, we need to save, and we need to rerun the test. And of course, something happened. And what did we do? We very cleverly added a return without thinking about the end of the line, and that was an if clause, so it ended with a colon. We left the colon, and we're going to delete it, write and quit, rerun the test. Now everything is fine. So again, having a test cover a function before you do anything to that function, no matter how trivial that is super useful. And I really made that error now. So back to the tutorial. Finally, head back to your local Galaxy and verify that the runtime error no longer occurs. Most importantly, remove the breakpoint statement you added to the datasets file. Heading to the terminal, the datasets were in lib, Galaxy, web apps, Galaxy, API, datasets. I don't remember where it is, but if I search for breakpoint, I'll find it. There it is. I'm removing it and I'm saving it. Start Galaxy and repeat the steps from the bug report. Well, run.sh, waiting for Galaxy to be served on port 8080, holding fingers crossed. Almost there. Not yet. And it's being served. Heading to Galaxy. Here's Galaxy. User menu. Datasets. Fingers crossed. And it runs. Congratulations. You have fixed the runtime error. And by this, you have completed the last section of this tutorial and arguably the most challenging section. Congratulations, and thank you for working through this. And stop share, stop recording. Thank you.